when dealing with switching between normal and emergency lighting powered by a generator, especially in a hospital setting, it's crucial to consider safety and code compliance. Here are a few options to consider, each with its own advantages and disadvantages. Firstly, we have the isolated switching option. This involves installing two separate switches in different locations. One switch is clearly labeled as emergency, and the other is labeled as normal. The key here is to ensure that each switch only controls its respective lights, preventing normal power and emergency power from being in the same box. This method adheres to the electrical code by keeping the different power sources separate, but it relies on users to operate both switches to ensure adequate lighting during normal and emergency situations. Secondly, consider using a generator interlock switch. These switches are specifically designed for use with emergency generators. They feature two inputs, one from the generator and one from normal power. The core function of this switch is to allow only one power source to be active at a time. When the generator is active, the switch allows only the emergency power circuit to be active. Conversely, when normal power is available, the switch allows only the normal power circuit to be active. This type of switch provides a more automated and reliable solution, preventing the mixing of power sources and ensuring that emergency lighting is automatically activated during a power outage. Thirdly, let's look at a smart switch solution with remote control. This involves installing a smart switch that offers remote control capabilities. The smart switch can be programmed to turn on both the normal and emergency lights simultaneously when activated from the remote control. The benefit here is that it ensures both lights are always turned on together, mitigating the risk of someone leaving the emergency light off. This solution offers convenience and control, but it requires careful programming and configuration to ensure it functions correctly during emergencies. The fourth option is a night light with an occupancy sensor. This involves installing a dim night light that is connected to the emergency power circuit. An occupancy sensor is then added to the night light, so it only turns on when motion is detected. This approach provides a low level of ambient light when normal power is off, while ensuring that the emergency light is not constantly illuminated. It's energy efficient and provides sufficient lighting for navigation during power outages, but it may not be suitable for all areas, particularly those requiring brighter emergency lighting. In addition to these options, there are several other important considerations. Ensure that emergency lights are clearly identified with appropriate signage to avoid confusion during emergencies. Train staff on the proper use of the emergency lighting systems, including how to operate the switches and understand the system's functionality. Consider installing a generator backup for the normal power circuit to provide additional redundancy and ensure continuous power to essential system. When selecting a switching method, it's essential to consider several factors. Firstly, compliance with electrical codes is paramount. All installations must adhere to the National Electrical Code, or NEC, and any local codes and regulations. Pay close attention to requirements for separation of normal and emergency power circuits, wiring methods, and equipment installation. Secondly, the specific needs of the hospital environment are important. Consider the size and layout of the rooms, the level of lighting required, and the needs of patients and staff. For example, patient rooms may require dimmer emergency lighting, while corridors may require brighter, continuous illumination. Thirdly, reliability is crucial. The switching system must be reliable and function correctly during emergencies. Regular testing and maintenance are essential to ensure that the system is always ready to perform as expected. Fourthly, ease of use should be considered. The switching system should be easy for staff to operate, even during stressful situations. Clear labeling and intuitive controls can help prevent confusion and ensure that the system is used correctly. Fifthly, cost effectiveness is a factor. While safety and reliability should be the top priorities, it's also important to consider the cost of the switching system, including installation, maintenance, and energy consumption. Evaluate the total cost of ownership for each option and choose the one that provides the best value for the hospital's needs. When selecting a switching device, understand its ratings. It is important to know the voltage, amperage, and horsepower if the switch is used for motor loads. For lighting, the ampacity and voltage will need to be known. The selection of wire and conduit size for normal and emergency circuits should adhere to NEC requirements. For conductor ampacity, refer to NEC Table 310.15b16 for allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees C through 90 degrees C. Conduit fill requirements are outlined in Chapter 9 of the NEC, specifying the maximum percentage of conduit cross-sectional area that can be occupied by conductors. Grounding and bonding are critical for safety. Emergency lighting systems must be properly grounded and bonded to minimize the risk of electrical shock and ensure the proper operation of overcurrent protection devices. Refer to Article 250 of the NEC for detailed requirements for grounding and bonding. Overcurrent protection is essential to protect emergency lighting circuits from overloads and short circuits. Circuit breakers or fuses must be sized appropriately to protect the wiring and equipment. Ensure that overcurrent protection devices are readily accessible and clearly labeled. Consider the location of the generator. The location of the generator should comply with local codes and regulations. It should be installed in a well-ventilated area and protected from the elements. The generator should be regularly inspected and maintained to ensure reliable operation. Consider automatic transfer switches or ATS. In many emergency lighting systems, an ATS is used to automatically switch from normal power to generator power during a power outage. The ATS should be sized appropriately for the load and should be regularly tested to ensure proper operation. Consider battery backup systems. In addition to generator power, some emergency lighting systems also include battery backup. Battery backup can provide short-term power in the event of a power outage or generator failure. Batteries should be regularly tested and maintained to ensure they are in good working condition. Consider emergency lighting control panels. Emergency lighting control panels provide centralized control and monitoring of emergency lighting systems. These panels can be used to manually or automatically control the operation of emergency lights and to monitor the status of the system. The panel should comply with UL 924, the standard for emergency lighting and power equipment. Consider the use of listed and labeled equipment. All equipment used in emergency lighting systems should be listed and labeled by a nationally recognized testing laboratory or NRTL, such as Underwriters Laboratories, or ALL, or Intertech, or ETL. Listing and labeling ensure that the equipment has been tested and meets applicable safety standards. Consider the use of emergency lighting in hazardous locations. If emergency lighting is required in hazardous locations, such as areas where flammable materials are stored, the equipment must be specifically designed and approved for use in those locations. Hazardous location lighting must comply with the requirements of Article 500 of the NEC. Consider the use of emergency lighting in healthcare facilities. Healthcare facilities have specific requirements for emergency lighting to ensure the safety of patients and staff. Emergency lighting in healthcare facilities must comply with the requirements of NFPA 99, the Healthcare Facilities Code. Consider the use of emergency lighting in high-rise buildings. High-rise buildings have specific requirements for emergency lighting to ensure the safe evacuation of occupants during a fire or other emergency. Emergency lighting in high-rise buildings must comply with the requirements of the International Building Code, or IBC. Consider the use of emergency lighting in places of assembly. Places of assembly, such as theaters, auditoriums, and churches, have specific requirements for emergency lighting to ensure the safe evacuation of occupants during an emergency. Emergency lighting in places of assembly must comply with the requirements of the International Building Code, or IBC. Consider the use of exit signs. Exit signs are an important part of emergency lighting systems. Exit signs must be clearly visible and must be illuminated at all times. Exit signs must comply with the requirements of the International Building Code, or IBC. Consider the use of directional signs. Directional signs can be used to guide occupants to exits during an emergency. Directional signs should be clearly visible and should be illuminated by the emergency lighting system. Consider the use of audible alarms. Audible alarms can be used to alert occupants to an emergency. Audible alarms should be distinct from other alarms in the building and should be audible throughout the building. Consider the use of voice communication systems. Voice communication systems can be used to provide instructions to occupants during an emergency. Voice communication systems should be audible throughout the building and should be designed to operate during a power outage. Consider the use of fire alarm systems. Fire alarm systems can be used to automatically activate emergency lighting systems. Fire alarm systems should be regularly tested and maintained to ensure they are in good working condition. Consider the use of smoke detectors. Smoke detectors can be used to detect smoke and activate emergency lighting systems. Smoke detectors should be regularly tested and maintained to ensure they are in good working condition. Consider the use of heat detectors. Heat detectors can be used to detect heat and activate emergency lighting systems. Heat detectors should be regularly tested and maintained to ensure they are in good working condition. Consider the use of sprinkler systems. Sprinkler systems can be used to suppress fires and protect occupants. Sprinkler systems should be regularly tested and maintained to ensure they are in good working condition. Consider the use of fire extinguishers. Fire extinguishers can be used to extinguish small fires. Fire extinguishers should be readily accessible and should be regularly inspected to ensure they are in good working condition. Consider the use of fire hoses. Fire hoses can be used to extinguish larger fires. Fire hoses should be readily accessible and should be regularly inspected to ensure they are in good working condition. Consider the use of fire hydrants. Fire hydrants can be used to supply water to fire hoses. Fire hydrants should be readily accessible and should be regularly inspected to ensure they are in good working condition. Consider the use of standpipe systems. Standpipe systems can be used to supply water to fire hoses in high-rise buildings. Standpipe systems should be regularly tested and maintained to ensure they are in good working condition. Consider the use of emergency generators. Emergency generators can be used to provide power to essential equipment during a power outage. Emergency generators should be regularly tested and maintained to ensure they are in good working condition. Consider the use of uninterruptible power supplies, or UPS. UPS systems can be used to provide power to critical equipment during a power outage. UPS systems should be regularly tested and maintained to ensure they are in good working condition. Consider the use of automatic transfer switches, or ATS. ATS systems can be used to automatically switch power from the normal power source to the emergency power source during a power outage. ATS systems should be regularly tested and maintained to ensure they are in good working condition. Consider the use of load shedding systems. Load shedding systems can be used to reduce the load on the emergency power source during a power outage. Load shedding systems should be regularly tested and maintained to ensure they are in good working condition. Consider the use of peak shaving systems. Peak shaving systems can be used to reduce the peak demand on the electrical system. Peak shaving systems should be regularly tested and maintained to ensure they are in good working condition. In summary, carefully consider the needs of the specific application, adhere to all applicable codes and standards, and ensure that the emergency lighting system is properly designed, installed, and maintained.